doing today? Okay, well, let's go ahead and get things started. Today, we're going to be taking a look at the complete guide to Rails performance, and we're going to be taking a look at section 5 of the book today, which is profiling with RubyProf and StackProf. So, the book starts out with a story. It's 9 a.m. You take a look at your performance metrics, and you're seeing a massive spike 500 milliseconds for your 95th percentile and 10 seconds on some, well, 95th percentile is 10 seconds, an average response time of 500 milliseconds. So tools like Skylight, New Relic, Datadog, everything else can give you a lot of data on these requests and a lot of insight, but what exactly do you do locally to take a look into some of these things? Well, that's where profilers and RubyProf, StackProf, and some of these things start to come in. So, one thing the book mentions is that these things are fine to run in development, but maybe not in production, because profilers are effectively asking your computer to show what exactly did you do, how much time were you taking, and add a lot of overhead to everything that you're doing. So, useful for development systems, yes. Sometimes in rare, very specific circumstances, useful for production, also yes, but much rarer. But the book mentions great, we have profiling, but what next? What exactly are we looking for? So it gets into performance workflow of monitoring metrics for problems. And we'll go into that a little bit later. One of the things the book mentions and that I've observed myself is that unless you have a metric, an objective measure, and it's something that you're trying to make either go up or down, it's really hard to prove that something actually worked or what exactly it is you're targeting. You're more going off of feelings and I think versus here's a solid, tangible needle that I can move up or down to see if this thing is actually working. So you have metrics there. The next step the book mentioned is profiling, which is why is it slow? Where's the time going? Is it in database calls? Is it in integer times? Is it in some random service object? Is it who knows where? I mean, in that recent capybara example I mentioned last time, I noticed that a massive amount of time was being spent in 2 or 3 places. The first one was in gsub, which meant something was doing a lot of text correction. The second is that Zeitwork was being hit a lot, which means that there are a lot of objects being loaded and probably something weird with file observers going on. And the third thing that we noticed in there is that there was a lot of sleep time, which meant that there was a lot of stop waiting for something to load on a page. And this is all for end-to-end testing this was on. Third step is setting a reasonable benchmark. Let's see here. So that's effectively measuring where exactly do we want to measure. Benchmark IPS, the book mentions, is also one of my favorites. If you've not seen that yet, let's see here. Well, we'll probably get into that. And then experiment with and benchmark alternatives. So the book mentioned this is more or less a very dressed up scientific method. So if we skip back over to here, essentially what the book is saying is 1, make observations, 2, three, and 4. So in a lot of cases, it's very similar to a lot of workflows I've used whenever trying to figure out why exactly is something slow, and in general is probably going to be one of the most useful ways you can go about this yourselves. I mean, especially in the make observations, but given those observations, it is going to be very important to actually have something you're aiming for and say, I'm pretty sure X is happening, or I'm pretty sure Y is happening. And of course, as you get more experience, you're going to find that this is a much faster step. And it's kind of like drawing or, say, coding or anything else, where the first couple times you do it, you have to write all your construction lines, you have to draw your circles, you have to sketch things in. But as you get better, you can start to skip steps. And all of a sudden, you can skip from a blank sheet of paper to something fairly comprehensive very quickly. So your guesses become more and more educated as you start progressing. Like, for instance, I took a look at something and said, I have no idea why in the world this is being slow at the site work phase or in the stop waits, but I'm pretty sure there's something wrong with it loading a ton of constants and a ton of different files for this massive GraphQL resolver. That makes no sense. So for me, I had a direction, I had a vague inclination, and then we handed it over to Nate and said, Nate, what do you think about it? Well, Nate took that and skipped about 3 or 4 steps and said, it's probably something weird with this file observer, this listener over here, because these things tend to be in this area and do these things. So for him, he skipped a whole bunch of steps right about the finish line there, which is impressive watching it happen. But still, for me, formulating hypothesis and being able to predict and actually deliver on that takes me a decent bit longer unless I have some skill in that domain. So if it takes a while to do this, don't worry about it too much. It takes everyone a bit when they're starting out. So the book then goes on to profilers or choosing a profiler. And then it's going into various modes of profiler or effectively what you're measuring. Like, let's say CPU. Let's go ahead and make a new Sandbox folder in here, just so we have a few of these things to play with. Okay, so go into Sandbox. Make sure we have RubyProf installed. Native extensions. Okay. Well, while that's waiting, new file. Let's call this it's not really benchmark, it's more a profile. Naming is still hard. Okay. We got that. So just to see what exactly this is doing. So RubyProp is measuring that. We have a result, which is running this sleeper function, and then it's going to be printing that out like that. And let's see here. RubyProf CPU time, okay. What am I doing using Vim instead of VS Code? Okay, we're going to go over to the other class. We're going to borrow this, yoink, and then we're going to make ourselves a gem file inside here. Put that in there. So we have RubyProp over here. Save that. Don't need that folder open. Install that, see if that helps. Okay, let's see what we got real quick. Debugging time, okay. Nope, okay. RubyProp, what do we got? It's Ruby 2.7. Let's see here. So there's probably something which changed since then. Let's see if we can find what it is. Wall time, process time. Okay. Okay, so process time looks vaguely similar. So let's try that. Okay, I don't need that to be too long. And then let's see if we got something vaguely similar. Okay, so that looks vaguely similar to what we have over there. So I'm going to go back over here and mention that I'm going to put this over in the Slack channel. Well, Slack channel, Discord channel. There are too many chat applications, you know? Okay, well, anyway. Yeah, if something like that ever happens with a book, and I mentioned this in last class, is that code gets updated way, way quicker than books get updated. So it comes to be expected that random little things will break every now and then. So your two options are either one, find out what it does now, or two, the lazy way, find out vaguely when the last book was updated, and then go over to Ruby Gems. Then let's see, Ruby Prof. Okay, and Ruby Prof had various releases. We have a bunch of those, yada, 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 yada. Okay, let's assume that the book was last updated, say 2019 or so. And we might have 018 right before that. Anyway, point being, find the date closest to when that book was released and then grab those gem versions. There's probably a way that you could hack this together to do that for you automatically, but we won't go too much into that. Anyway, distractions. Okay, so let's see what we got here. The book mentions, take a look at the total column over here, and that is at 0. We know it takes 4 seconds, but sleep suspends the thread, meaning that we're still in CPU time and number of clock cycles, at least I think. And feel free to correct me if process time is the incorrect one, but the results look vaguely similar, so I'm going to guess probably that's what its name is now. Okay. Let's say we gave a thread 4 seconds of busy work. Let's call this sleeper and then sleeper 2. That way we have a little bit of difference. Time is equal to time.now for that. Do nothing. Okay, so we have that. Let's clear that and see what we got. That's noisy. Okay, sleeper 2, about 3.859 seconds. Okay, approximately 4 seconds inside sleeper, which is what we expect. Okay. Okay, book goes into a lot of detail about CPU stepping. We won't get too much into these. I'm going to leave that for an exercise of the reader. Okay. The big point out of this is mentioning that using CPU time is preferable whenever you're interested in seeing a profile without IO, kind of like sleep over there in the first version. That's not going to get captured as we saw there. Let's see here. So wall time, let's see what we got here. We profile sleep with wall time, we'll get where exactly is wall time on there? Ruby prof, give me wall time. Wall time. Okay. Let's try that out. So it mentions wall time is very similar to whatever clock time is displayed on the Okay, well, let's make sure we're using sleep 1 instead of sleep 2 over here first. Okay, put that over there. 2, 3, 4. Okay. So it gets that. Sleeper's at 4 seconds, so that's as expected. Good, good. Okay, and that uses get time of day to measure things. And apparently wall time can be affected by other processes and network or I/O conditions. That said, the book mentions this is probably what you want to use for most I/O, or rather most benchmarks. Except for network requests, don't use wall time when lots of I/O is involved and is highly variable. Okay, so process time is different than CPU time, apparently. So that's an entire thing. Okay, we're learning something today, including myself. Okay, so the difference between CPU time and process time that the book is mentioning is that Ruby prop is using a clock function. Process time measures time between a process and any 2 moments, unaffected by other processes concurrently running on the system. But it mentions there's a weakness here, which is that time spent in child processes isn't going to be measured. It does mention, though, that process time is a better choice than CPU time, which I guess is amusing because if we go back over to this, we'll notice that CPU time is no longer on there and process time is left over. So I guess that's natural successor then. So, okay, mostly correct. So CPU time doesn't even exist anymore. Interesting. Okay. What profilers measure and how? Okay, we have the x-axis on a profiler, which is variable of time. Now y-axis, which is what are we going to measure and how? Okay, so the book mentions a program, so we'll just go ahead and put this over here. A, B, def B, hello. And then if we actually saw that being processed, it would give us a stack looking somewhat like this. Okay. Profiles keep track of stack over time. A lot of flame graphs and other things are also going to be very stack dependent, so that's probably going to come up fairly soon here. Okay, so it mentions that profilers differ in when exactly they decided to take a snapshot of the current stack. Okay, book goes into tracing over here. Okay, so it mentions that Ruby prof is a tracing profiler, meaning it tries to be accurate as possible by measuring every method invocation, how long they take, aggregating across multiple runs. Extremely accurate, but very high overhead is what it's mentioning. Okay, so Ruby Prof is literally just a C extension running inside the Ruby VM along with the program. Yeah, unfortunately, a lot of profilers tend to be very low level to hook into a lot of native events from the language itself. Okay. So then the book goes into sampling, which is saying with tracing and everything we've done so far, we're literally watching everything, which has a lot of overhead and can be very noisy. But you could also use sampling, which is let's get a narrower subset of that of things that we actually want. And a Stack Overflow answer they quote in the book is just halt your program several times. Each time look at the call stack. If there's some code that's wasting percentage of time, 20, 50%, or whatever, that is the probability that you will catch it in action on each sample. So that is roughly a percentage on samples of which you will see it. There's no educated guesswork required. You don't have to guess to what a problem is. This will prove or disprove it. Let's open up that example real quick. No, don't. Pesky thing just opened in the same tab. Okay, well, getting back to which page we were on, let's go back to sampling, 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 sampling. Okay, so let's copy the link address and go over to here, open that up, put that here, and that is the answer they happen to be referencing. And particularly right here. Anyway. Let's see what we have left over here. Okay, so back into a section on Ruby Prof. Great for profiling and development, hooks directly into MRI in the Ruby VM, and the program's probably going to run 2 or 3 times slower. The book does mention that if you're wanting to run this in production, use a sampling profiler instead, which was mentioned above, which is don't cover everything, only what you want. So there's an example back whenever I used to work at PlayStation to where we had a request from one of the data science teams of we want every controller action on a PS4 controller. What do you mean by every? You'd ask. Well, they meant literally everyone across every console across the world because they wanted all that data to be able to measure against. So me kind of scratched my head. I'm like, you do realize how much that's going to cost? Like, no, we want that data because that data is going to be useful to us. Well, as soon as we flipped the equation and said, yes, but here's the bill and it's cost attributed to your team, all of a sudden they weren't so fond of that idea anymore. And then they took a look at the data and said, maybe we don't need multiple terabytes of data every minute to measure how in the world we're doing that. And they decided to dramatically shrink the request into something far more reasonable. So do be aware of the cost of what you're doing and how that might impact your systems, your AWS budget, Heroku budget, name other thing here budgets. Anyway, side story. Okay. Let's see here. We have quick and dirty profiling. So let's write ourselves a new benchmark over here. We don't need this anymore. Let's make sure that we have, let's call it B-Search profile. So we have that. Benchmark IPS. Make sure that's installed. Okay, so we got that. We got that. Okay. You know, I know that everyone uses X there, but I prefer benchmark to remind me of what in the world X even is, especially when we use that as a sample variable later. Anyway. 10,000, okay. And a random number around 100,000 size. Sort that. Book doesn't make this constant, I'm going to make that constant. Okay. Benchmark.report, grab that. Okay, so we have that. We need to implement both of those methods. Huh. Okay. So book doesn't actually give the implementation of those methods. So we'll just go by some of the examples they're mentioning here, just so we have those. Okay, so output is that bsearch2 should be 2 times slower. It'd be nice to see an implementation of those to know what exactly they're trying to do here. Okay, so the measure out of that was this. Still process time over there. Got that, got that. Then we'll go ahead and copy over the output again. Okay, so let's see what we got here. So the book is going to go into what each one of these headers mean. Percent self is percent of total time elapsed in its method call. Total is the time spent in the method and all of its children. Self is the time spent on the method excluding child calls. Wait is the time spent waiting there. Child is time spent in child processes, and calls is number of times it's invoked, and name is, well, the name of the thing. Self, total, self, wait, child calls, name. Okay. So what it's saying here is whatever's calling double equals here is fairly hot path, which is taking a majority of the time of about 71 seconds there. And what the book is mentioning is start with the biggest percent self and start optimizing down from there. Okay, so let's see what we got over here. And then the book goes into mentioning StackProf, which is used under Rack Mini Profiler, and unlike RubyProf, it samples rather than traces, making it useful in production. Nate mentions not very useful in development, since RubyProf is more accurate, but if you're looking for production, definitely use that. Let's see here. Wall timing and CPU mode supported. And let's see here. Checklist for your app. Use a profile like RubyProf to diagnose application startup time. Where does most of your time go? And find an algorithm or other hot Ruby code in your app. If you can't, find 2 different implementations of a common algorithm like binary search, and then try and figure out which one's better optimized. Let's see here. Lab 1. Okay, so let's see here. Go back into parent directory. Let's see about exercise 1 right here. So it mentions clone Dolly. One thing about this, though, is that this application may well have been updated since that. So let's see the into Dolly, bundle. And then run its benchmark test to see what we got here. Give that a second to run. What exactly is Dolly anyway? Pure Ruby memcached implementation. Well, client. Let's see here. So that was over in test benchmark tests. Let's see what exactly benchmark test is doing. File, profile HTML. Okay, so that's why we're not seeing those examples right there. So let's go ahead and copy that path. Where's that? Relative path. Gem install launchy. That way we can just open that from here. Fine. Just use open. Liar, I can see right there. Okay. Oh, right. I'm in the actual directory. That does help. Okay. Open that. And I'm going to put this window up just so I can put this in here. There we go. Okay. That is all types of small. Let's see what we got here. Okay, so now they have a nicer HTML output since last time the book was updated. So that's what we're going to take a look into. So if you are doing this, I'm going to mention that over in the Discord channel real quick. we got that. Okay. So let's see what we got here. Percent self, 37, 37, 37, 0, 0. Integer time gets called a lot, so that's taking a little bit, but not much. Let's give me something a little bit. Delay client perform. Kernel loop is taking a good amount of time there. And IO wait is taking about 15% of the time. And what the book mentions is that delay is spending about 30% of the time on that reading, writing in IO methods, since it's fundamentally a library for taking database calls. And it says almost all the methods take less than 3% of the time, meaning it's fairly well optimized. And since the book, it looks like the IO read wait, or rather wait readable, has been optimized a little bit more, or some of the other methods are taking a little bit longer. So let's see here. Just out of curiosity, what else do we have? I mean, read non-block is taking 8% of the time, which is still in kind of the read locking. IO write's taking 6%. Standard requests takes a little bit. That might be interesting. Let's see here. Nothing else is taking a lot of time. B search. Yep, it doesn't look like anything else is particularly taking a significant amount of time. We're running out of little blocks of code to hit here. Let's go all the way to the bottom. Okay. So it looks like a lot of threads and fibers are running on there. Anyway. So it looks like they have updated it a little bit to have that web page. So if you are running this, make sure to be aware that it's being put into a profile.html page. Otherwise, you can be very confused why it's not giving you anything down here. Because if you look at this, all we're getting is a bunch of users, system time, and everything else like that right here. So anyway. And I think that is all there is to this section. So did anyone have any questions or topics they'd like to cover? Okay. Well, if not, we can go ahead and call that a day and go from there. If you are looking for any additional resources or help on these classes, feel free to join us at rubylearning.dev. You can find a link to the Discord. I'm also going to be trying to post any solutions to random issues I encounter as I'm running through these myself, and we'll post those in the channel as we go through them. For the most part, I try and go through these mostly blind just so you get more genuine reactions as to what I've run into, how I debug this stuff, and how I think about that whenever I get to these things. Some books like Effective RSpec I've already read before, so it's a little bit cheating for me. This book is more of a first run for me. Anyway, with that all said, thank you so much for your time, and we will see you next for session number 6 in here, which is on Rack Mini Profiler. Well, thank you so much for your time, and have a great day.